Hi, we're here with Professor Dr. Albert Heuberger, Executive Director of Fraunhofer Institute for Integrated Circuits, which is abbreviated Fraunhofer IIS. We want to get his perspective on innovation and technology. Hi, Albert.
Hi, Brett.
So let me start out with we're approximately the same age. When you started out in 1987, did you have any idea how technology would develop over the next 35 years?
Yes, in '87, I started as a young engineer for communications and RF and microwave. And I was very excited about all the new possibilities in microelectronics. And of course, we saw all the grand challenges we faced. Computers with 1 gigahertz clock rate, transmission rates of 1 gigabit per second and above, and complex digital and analog chips. And over the time, we've been developing those. We have been developing our skills, learning, expanding our views, our perspectives, even setting some trends. And now here we have come along the way, driven by curiosity, the will and ambition to make impact, drive forward the state of the art. And now here we are. We have clock speeds at 5 gigahertz in a laptop computer, wireless transmission, 5G, 6G in millimeter sub-terahertz waves, billions of transistors on a chip. And at that time, 35 years back, we had no idea where this should lead us. And so it's been an exciting time since then.
Yes, it's gone way beyond Moore's law.
Yeah, and even though one should say that it was difficult to predict at that time what would come, it's today, from today's perspective, it's even more difficult. If you would make the attempt to look 35 years in the future. And as you mentioned, Moore's law, a governing rule and governing guideline, it will slow down and eventually come to a halt, maybe limited by the laws of physics and also by the laws of economics to some extent. And so I think that additional technologies will come into play and will play a more important role on innovation in microelectronics. And I see here three main areas, the one being the heterogeneous integration, where combinations of chips and chiplets with different technologies providing new functions will be put together and making the difference in the product. That we have new technologies like gallium nitride and 3.5 for optoelectronics and RF will also come into play and will be integrated. And thirdly, also the role of designing complex chips will be even more dominating also the way how we are doing innovations and drive forward technology, because all our system know-how will be more and more be incorporated into digital designs.
Okay, great. So now, one of the things that I think is always interesting to look at is how different societies go about innovating. We know that the semiconductor is sort of the oil of today. It's a big deal. So in terms of innovation in general, Europe relies heavily on RTOs, research technology organizations like FMD, for innovation. How would you compare the different structures that are used for innovation in Europe with other geographies where they do things a little bit differently, or do they, especially in North America and China?
Yeah, so in Europe, we have a number of RTOs, IMEC, LITI in France, and also FMD in Germany and others in other countries. And they are playing indeed an important role in helping innovate microelectronics and helping industry, in particular small and medium-sized companies. And I can specifically, of course, talk about FMD. And I would say that the unique role the FMD is playing in this innovation game is the strong link between academic research and the transfer to industry. Yeah, and we do this through our state-of-the-art lab infrastructure, which is able to provide also fairly elaborate and fairly well advanced developed prototypes, and going up until a TRL of up to 8, and also provide small and medium volume production even for those microelectronic systems. And I think this helps the industry, and in particular small and medium industry, a lot to innovate and to bring new functions, new technology into play and into the market. Huh? And so this fills an important gap between prototyping and large volume production, which is taken over by large companies, large foundries, and those foundries are not interested in doing small volume business. No? And so that's usually the dilemma these small and innovative companies have, and even larger companies who are bringing up a new technology, but in small volume. Yeah? And so we think that in this model, together with our funding model, where we will acquire 2/3 of our budget from external projects, will play a very unique role. And so this makes us unique in comparison to what you mentioned, the systems in the US and China, no? Where you have the large industry labs, where you have large industries in research centers, or the basic funded national labs.
Mm-hmm. Okay, so
which doesn't say that this is not effective infrastructure, but I think what we are offering is quite unique also in terms of the contribution to the innovation.
Absolutely. So as an American living in Europe, I get to see this, and I think it's fascinating to see the way different cultures deal with innovation, and it's an exciting time to be alive because we have so much going on now. And what do you think can be done more, though, to stimulate more the entrepreneurial spirit in, let's say, Europe and or Germany, or both Europe and Germany? What can we do to get more entrepreneurship?
Yeah, first of all, you need people. Yeah, you need those young talents and these driving forces of innovation who have new ideas and want to bring this into application. And so this is the entrepreneurial spirit, where it's always said that the Germans are not, or the Europeans are not that agile and even ambitious, but it's as it is. And what we can do is to provide low threshold access to microelectronic products, which is helping those smaller companies and startups. First, for example, by providing Europractice, low volume chip design access, cheap design and implementation of prototyping and engineering samples, as well as helping with certain production technologies for new products. And so this is one of our missions, to specifically help these new companies. And there's also, from government funding, numerous activities in incubation and acceleration of innovation, particularly in the microelectronics business, where you have usually the dilemma of the high technological threshold, needing a lot of investment, which is also to some extent a problem for startup companies.
Okay. All right. So in terms of the technology itself, or in the near future, what do you see as the big challenges in technology in the near future?
Yeah, of course, the microelectronics is a worldwide, very distributed, complex technology where you have a lot of players interacting and very complicated and entwined supply chains. So it's no way in dreaming of some sort of autarky in technology. So it's always a cooperation on international level. And so the big challenge would be, to me, that these cooperation mechanisms, supply chains for raw materials, precursor materials, technologies, and so on, will work properly in the future. Yeah, and so we have seen in past incidents that these supply chains they are quite sensitive, and even small events can trigger very severe consequences. And so my hope is, and my challenge, and the challenge I see is to keep this still working, also driven by the need of new talents, young future experts who will make sure that these supply chains and this interworking of innovation and technology will be maintained. Yeah, so this is a question and a challenge to us all, and particularly also for me, as I'm a academic, also working on academic education. So to help maintain this supply of new talents. And thirdly, the challenge is that all these geo-strategic situations with China, US, Taiwan, and so on will still be in a state that there is continuously maintained, and that no severe interruptions will take place.
Okay. Well, thank you for your insights and your perspective on innovation and technology.
So, thank you, and you're welcome. It was my pleasure.
Okay. Goodbye.
Goodbye.